You probably think um, that the future of AI is locked inside these massive billion-dollar server farms.
Right, those sprawling data
Yeah,
centers.
the ones the size of entire city blocks, just
Yeah.
humming with thousands of processors just to answer our everyday
That's
questions.
what we hear about constantly.
Exactly. But what if the real revolution is actually happening right inside the device in your pocket?
Making advanced AI essentially free to use.
Yes, exactly. Welcome to today's deep dive. Our mission today is to help you understand this massive shift from expensive cloud-based AI to what is known as edge AI.
And how this shift is, fundamentally rewriting the rules of global education and workforce training.
We are exploring this through a really fascinating stack of sources today, primarily a March 2026 white paper and a press release from EON AI Ventures.
The title of that paper alone really grabs your attention. It's called Apple Gave the World a Free Brain.
Such a bold claim. And they detail this phenomenon called the Great Infrastructure Inversion.
Right, the core idea being that the staggering costs of AI are suddenly just collapsing.
And companies are leveraging this to build a structured content layer that operates entirely off the grid.
Yeah.
But to understand where we're going, we first have to look at the massive financial roadblock that has held global AI back until now.
The cloud tax.
The cloud tax.
If we look at the numbers from the source material, the scale of that roadblock is almost difficult to comprehend. I mean, in 2025, global hyperscaler AI spend was $700 billion.
Wow. 700 billion.
Yeah, that's just the money poured into infrastructure by the tech giants. Meta alone was spending over $135 billion annually just on their infrastructure.
Okay, let's unpack this. Because why is that price tag so astronomical? Like, what is physically happening when we use cloud-based AI that costs these companies hundreds of billions of dollars?
Well, the mechanism driving that cost is called cloud inference. For the last decade, every single time you asked an AI to, say, generate a lesson plan or translate a paragraph.
Or summarize a dense manual, right?
Exactly. Your device didn't actually do the thinking. It sent a query through the internet to one of those massive data centers.
Right.
And in that facility, these massively power-hungry graphic processing units, the GPUs, had to wake up, crunch the data, and then send the answer back to you.
So every single interaction carried a metered cost.
Yes. Electricity, cooling, hardware depreciation. It is an incredibly resource-heavy supply chain for just a single digital interaction.
So if you want to scale an AI-driven education platform globally, especially to emerging markets where affordability is critical, that metered cost adds up instantly.
Oh, it's prohibitive.
It's like we've been paying a heavy toll every single time we wanted to look up a fact in an encyclopedia. You're paying server and energy costs every single time a student practices a skill.
It creates a totally insurmountable barrier to global adoption.
But that dynamic is exactly what has been upended by Apple's latest hardware, right? Specifically the M5 chip.
Yeah, the M5 chip utilizes an architectural breakthrough called Mixture of Experts, or MOE for short.
MOE. How does that actually solve the energy problem, though?
Well, instead of building one massive monolithic AI model that has to fully power up for every single question you ask it, MOE acts like an incredibly efficient dispatcher.
Okay.
It routes tasks to tiny, highly specialized submodels. So if you ask for a text translation, the chip only wakes up the specific expert submodel trained for translation.
Leaving the rest of the neural network dormant.
Exactly, which drastically reduces the computational overhead and the energy required. It allows advanced AI workloads to run locally on the hardware itself.
It just bypasses the cloud entirely. Apple just handed everyone their own personal free encyclopedia.
That's a great way to put it. Apple spent about $14 billion developing their AI capabilities in 2025.
Which is a lot, but compared to Meta's $135 billion.
It's a fraction.
Yeah.
And because Apple distributes that intelligence across 2.5 billion active devices globally, they effectively unlocked zero marginal AI cost at the edge.
Every time you ask the on-device AI a question, it costs exactly $0 in server fees. The toll booth has been completely demolished.
What's fascinating here is the vulnerability this exposes for the massive hyperscalers.
Oh, absolutely.
Think about it. The companies pouring hundreds of billions into remote cloud infrastructure are suddenly anchored to a depreciating heavy asset.
Because they lack direct access to the device layer.
Right. The physical hardware you actually hold in your hand, they are stuck in the old metered paradigm while the processing power moves directly to the user.
Which brings us to a massive question regarding application. Because now that Apple is handing us this free brain with zero marginal cost.
Is raw intelligence actually enough?
Right. If we want to train a technician to maintain an electrical grid or, I don't know, teach a medical student a complex procedure, is it enough to just hand them a super smart conversational AI?
The short answer is no, absolutely not.
Yeah.
There is a critical distinction between generic AI and specialized high-stakes applications.
Yeah.
I mean, generic AI is brilliant for drafting a marketing email or brainstorming project ideas.
Sure.
However, it generally delivers about 80% quality and is prone to hallucinations.
Confidently presenting false information as fact.
Exactly.
And an 80% success rate is perfectly fine if I'm asking for a dinner recipe, but it is absolutely terrifying if I'm asking for the sequence to land an airplane.
Or calibrate heavy industrial machinery.
Right. High-stakes operations like healthcare, aviation, advanced manufacturing, they don't have a 20% margin for error.
No, they require 100% precision. If an AI hallucinates a single metric during an infrastructure repair simulation, the real-world consequences are catastrophic.
And this is where EON AI Ventures steps into the picture. According to their white paper, they have 25 years of experience in extended reality.
With over 136 million platform downloads, yeah.
But what really stands out is their positioning. They sit above the device layer to provide what they call the structured content layer.
They're capturing that raw, zero-cost AI computing power from the Apple M5 chip and wrapping it in strict guardrails.
Transforming a generic language model into meaningful credentialed learning experiences.
Ones that are bound by real-world physics and strict industry standards.
Now, here's where it gets really interesting.
Yeah.
Because I have to push back a little bit on this.
Sure.
I am looking at device manufacturers like Apple or those massive cloud hyperscalers we talked about. They have functionally infinite capital.
They do.
So wait, couldn't the device manufacturers or massive AI hyperscalers just build this training layer themselves? If Apple holds the keys to the chip, why not build the ultimate learning platform natively?
It's a fair question, but it comes down to fundamentally different core competencies. Hardware manufacturers and OS developers are built to provide the foundation.
Right.
They lay down the digital concrete, they build the roads, they do not possess the specialized pedagogical curriculum
Right.
or the complex industry-specific credentialing networks.
The deep enterprise workflow simulations, all of that.
Yeah. Exactly. A dedicated platform requires all of that. EON has spent 2.5 decades building out those specific, highly regulated learning pathways for enterprise and higher education.
So a device maker is simply not structured to operate as a global university and a heavy industry compliance certifier at the same time.
Precisely.
Okay, so the bottleneck of global education has fundamentally shifted. It's no longer about accessing the intelligence.
It's about structuring and verifying the skills.
So let's explore what these zero-cost structured tools actually look like when they're put in the hands of a worker or a student in the real world.
The white paper outlines a few core capabilities within EON's ecosystem that leverage this edge compute. The first is EON Genesis.
And Genesis uses the on-device AI to generate 3D learning environments, right?
Yes, through a technology called Gaussian splat rendering.
Gaussian splat rendering. I have to admit, that just sounds like a messy sci-fi paintball game.
It really does.
But practically speaking, how does a mobile device or a headset actually render a high-fidelity 3D environment without just catching fire from the processing strain?
Well, traditional 3D rendering uses complex polygons. Think of them like millions of tiny, rigid geometric tiles.
Okay.
Rendering those requires massive computational overhead to calculate the light and angles every single time you move your head.
Which is why you usually need a powerful gaming PC or the cloud.
Right. But Gaussian splatting completely changes the math. It represents a 3D scene as a cloud of overlapping semi-transparent color blobs, or splats.
Ah, splats.
Yeah, because it relies on a much simpler mathematical representation of light and space. It drastically reduces the processing power needed to render a hyper-realistic space.
So that is the exact mechanism that allows these incredibly dense, high-stakes simulations, like operating a virtual turbine, to run natively on an edge device.
Smoothly and without needing a cloud supercomputer to render the graphics.
Incredible. And then there's EON Field IQ, right?
Yeah.
Their AR-guided procedural training.
Yes.
If I'm a factory worker, how does using EON Field IQ actually change my day-to-day compared to just reading a training manual?
Well, you are no longer looking away from your workbench to scroll through some massive PDF. The AR is recognizing the physical equipment right in front of you,
So it's projecting the exact procedural steps into my field of vision.
highlighting the specific valves or wires you need to touch. And crucially, because it is processing entirely on the edge, on the device itself, there is zero latency.
No lag.
None. There is no waiting while the headset sends a video feed to a server to ask what you are looking at. The feedback loop is instantaneous.
Which has to drastically accelerate what they call the time to competency.
Exactly. You build muscle memory faster and make fewer errors because the guidance is spatially and contextually locked right to your environment.
And they pair this spatial training with EON Brainy, which is their conversational AI.
Right.
The source mentions it uses social immersion for language learning and soft skills. It acts as an active role player, guiding you through scenarios and verifying your responses.
And ultimately logging a verified credential, all without constantly pinging a server.
Which leads us to perhaps the most vital implication of this entire shift away from the cloud tax: the global unlock and data sovereignty.
Yes. The impact on global accessibility is huge.
The white paper highlights the billion-learner market unlock. EON operates a global virtual campus offering accredited degree programs to over 80 countries.
They're specifically targeting low-income, high-potential regions.
Right. And Dan Lajerskar, the chairman of EON AI Ventures, states this shift to edge AI is the exact tailwind they have been anticipating for over 2 decades.
Because by removing the cost barriers once tied to cloud inference, they can accelerate global learning outcomes in ways previously unimaginable.
When the ongoing cost of running the intelligence drops to absolute zero, you can deploy world-class education to a student in a developing nation without racking up metered server bills.
Bills that would normally bankrupt the program in a week.
So what does this all mean? We are looking at the democratization of high-level education, reshaping the global workforce.
It's a massive shift.
But I have to raise a critical pushback here. The white paper mentions an impact share financing model to reach these regions.
Right.
But doesn't this impact share model still completely rely on people in emerging markets being able to afford expensive Apple M5 hardware in the first place?
This raises an important question, and it is honestly the central tension of edge AI right now.
Yeah.
How do we balance software affordability against hardware distribution? The impact share model functions as a financing mechanism. It pools institutional investment to subsidize the upfront cost of the hardware for the learner.
And then the investors recoup their outlay through the verified skills and increased earning power of that newly trained worker.
Exactly.
But why does that financing model only work now? Why couldn't they just do that 5 years ago?
If we connect this to the bigger picture, it comes entirely back to the cloud tax. If every lesson a student takes and every 3D simulation they run costs the sponsor 2 cents in server compute, the more the student learns, the more the sponsor is financially penalized.
Oh, wow. So it was an infinite, unpredictable liability.
Precisely. By eliminating the marginal cost of the software through edge AI, the financial equation finally stabilizes.
Because you can easily finance a fixed, one-time hardware cost over several years. You cannot finance an infinite metered server bill.
The elimination of the cloud tax is the mechanism that makes global hardware distribution mathematically viable.
That perfectly crystallizes the magnitude of this infrastructure inversion. Taking the system offline solves the financial barrier, but it also solves a massive enterprise hurdle.
Data sovereignty.
Yes.
For organizations handling highly sensitive information like military defense contractors or healthcare networks bound by IPA regulations.
Or advanced manufacturing firms with proprietary design.
Right. The idea of constantly sending their internal data back and forth to a third-party cloud server is just a non-starter. The security liability is simply too high.
But a closed device deployment means sensitive enterprise data never has to leave the device.
Exactly. If an aerospace engineer is using EON Field IQ to practice assembling a classified engine component, the AI analyzing their performance is localized.
The intelligence exists entirely within the perimeter of the physical hardware itself.
The AI operates within a secure silo. It grants enterprises the ability to use state-of-the-art training without ever exposing their trade secrets to the open internet.
Let's bring this all together for you. We started by examining a massive structural flaw in the current tech boom: the hundreds of billions of dollars tied up in cloud processing fees and server farms.
And we explored how Apple's M5 chip uses mixture of experts to drive the cost of AI processing down to zero directly at the device level.
And we saw how companies like EON AI Ventures are capitalizing on this by acting as the essential structured content layer.
harnessing that raw power with Gaussian splatting to deliver 100% accurate, high-stakes learning environments that don't rely on expensive cloud servers.
It is a massive leap forward, bridging the gap between factory floors and global classrooms. But it leaves us with one final thought to mull over.
What's that?
Well, if on-device AI can give us a highly capable free brain that handles our professional credentials, high-stakes training, and academic degrees entirely offline,
Yeah.
what happens when this technology essentially becomes the central repository for everything we know how to do? In a future where your device structures your entire educational and professional framework, who truly owns your skills? You or the platform powering your brain?
That really is the defining cry of this next era of computing.
Something to think about next time you reach into your pocket.
Thanks for joining us on this deep dive.